Functions seems to be a topic that students dislike, but actually functions is really easy. You just need to be taught it in the right way. You engage with it and you'll realize that functions is great and you're going to have a great time. What are functions? So in primary school, you may have seen function machines that look like this. And I don't know, you may have gone to like the computer rooms and then you have this program. And what you'd do is you'd just type in all these numbers and then it'll go inside the function machine and then a number would come out, right? This is basically what we're on about today, but we're going to be looking at it in a more formal way. So what you do, in primary school, you might take a number like the number 5, then it'll go inside the function machine. Then the function machine says it's going to multiply the number by 2 and then add 3. So if you take the number 5 and you multiply it by 2, which gives you 10, and then add 3, the number that comes out is 13. So we need to know some formal maths terms regarding functions. So what's important here is that when you put one number in, one number comes out. And that's very important. It would be a terrible function if you put one number in and all these different numbers start coming out. Now, these are some very important definitions. What you put into a function is called the input. That makes sense, right? Look at the function machine. Input. The more formal way of saying that is input. What comes out is known as the output. So the output, yeah? And this comes to our function notation. What goes into your function are the x values, and what comes out is your y values. So if you take x, and you put it into this function machine and you multiply x by 2, we all know if you take x and you multiply it by 2, you get 2x. And then add 3. Then you add 3. So to whatever x is, you multiply it by 2, and then you add 3. Now, how does this look in proper function notation? This machine, we call it the function machine. We call it F. Usually we call it F anyway. Sometimes we like to use G or H or whatever. Just for this demonstration, we're going to call it F for function. Now you take x, you substitute it into the function machine. When you substitute it into the function machine, we write this, f of x. So you're taking x and you're substituting it into f. When you do that, that equals 2x plus 3. Hey guys, I hope you're enjoying the video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button and comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video. So let's make sure we know how to work with the algebra of function notation. So given that f of x is x cubed plus 1, write down what this function does. So in general terms, what this function does is it takes the input, it then cubes it, and then adds 1. So in English, that's what it's doing, yeah? So f of x is x cubed plus 1. Whatever the input is, remember x is the input, it's going to cube that input, and then it's going to add 1. So for part B, it's saying what's f of 2? So the input has changed to the number 2. It's going to take the number 2 and it's going to cube it and then add 1. Yeah? I'm just going to highlight what we're comparing. So the 2 and the 2 here is the same as the x's. We're changing the inputs, yeah? f of x, x is the input. Now we just work it out. 2 cubed is 8 plus 1 equals 9. Right. Given f of x equals 3x, what would you guys say f of x plus 1 is then? F of x plus 1. See if you guys really understand. Milana's saying 3x plus 3. We'll double check in a second, see if there's any other answers here. Any other suggestions? X plus 1 plus 3x. Okay, Tyler's saying 3x plus 1. Now, go back. It's very important you listen to how I describe the function. Yeah? So, you go back to the original function. You're saying, what does f of x do? Whatever the input is, yeah, the input is x. We take that input and multiply it by 3. 3x is saying the input is being multiplied by 3. Yeah? So we are now changing the input to x plus 1. So the function multiplies the input by 3. So we're doing 3 lots of x plus 1, which you can expand to give you 3x plus 3. Okay, this is an interesting question. It looks very similar to part C. It is different though. F of x cubed on the outside. With the cubed on the outside, what it's telling us to do is to cube the whole function. Another way of writing this is we are doing f of x cubed. That's what that means. Yeah? F of x, the output is 3x. And it is asking us to cube that. Now to cube 3x, you cube the 3 and you cube the x. 3 cubed is 27 and x cubed. So in terms of this, what are we doing? We're saying, look, remember f of x is your outputs, which we call y, the outputs. No worries, Tyler. So we make it like that. We say y equals 3x plus 2 over 3. Now remember, what we're doing by doing the inverse is we're switching the x and the y's. So wherever you see x, you're going to replace it with y, and wherever you see y, you're going to replace with x. Now your only job now is to rearrange back for y, and that will then tell you the inverse function. Now, rearranging shouldn't be too difficult for you guys. So we get rid of the 3 first, so we times both sides by 3. So that goes, so we get 3x equals 3y plus 2. Then we move the 2 over. And then finally, we need to get rid of this coefficient 3. We divide both sides by 3. And then finally, because we swap the x and the y's and we rearrange back for y, this is the inverse function. So we say f minus 1x is now 3x minus 2 over 3. Now, because it's just a rearranging task, I want to show you guys how it works with more difficult functions. But really, it's not that difficult because we know we've done algebraic fractions. We all know, after doing all this hard stuff in October, how to rearrange. So if f of x equals x plus 1 over x minus 2, find the inverse. So remember, we rewrite f of x to be y is x plus 1 over x minus 2. Then the inverse function. Wherever you see x, we're going to write y, and wherever you see y, we are going to write x. And then we now need to rearrange for y. So we need to get rid of denominators. Remember, step 1 in everything we do is we get rid of denominators. So this y minus 2, we're going to times by y minus 2 on both sides. So this cancels, and we're left with x times y minus 2. Now, remember we're rearranging for y, so we need to expose the y by expanding in. So we have xy minus x times 2 is 2x equals y plus 1. Now, we rearrange for y by now bringing all the y's to one side and everything else goes to the other side. So we factorize out the y, and then finally we divide by the bracket. Yeah, to get y on its own, we divide both sides by x minus 1. But then don't forget, we change y back to the inverse. So we say the inverse is 2x plus 1 over x minus 1. Right. Composite functions, the last bit. Composite functions basically means applying more than one function to a number. So you have an input, you apply a function to it, and you get an output. Then to that number, you apply another function, g or something, to get another output. Now, it is very important that you read in the correct way. So it says, say I gave you two functions, f of x equals 2x minus 3 and g of x equals root x. What do you think f of g of 16 means? The 16 is in a bracket with g, yeah? Which means we apply g of 16 first. We apply g of 16 first. That's what it reads, right? We just have that f further to the left. Now, g of 16 means wherever you see x, you're going to replace it with 16. So it becomes root 16, which is 4. Keep in mind, this is not the square root function. There's no plus or minus there. It's just the root function, which is positive. Now, if g of 16 is 4, can you see there's an f there on the left side? If you put an f there on the left side, you put an f still on the left side, you're doing f of 4. So you sub in 16 into g, and then wherever that number is, you sub that into f. You're reading backwards, basically. Now, f of 4, what's that? Wherever x is, yeah, you sub in, you times it by 2 and then minus 3. So you're doing 2 lots of 4, and then you minus 3. So in summary, f g of 16, you take 16 and you sub it into g, which gave you 4, and then you sub that 4 into f, and that gave you 5.